What is cloud computing? Welcome to our What is Tech series, where we explore the latest advancements in technology. In today's episode, we'll be discussing a fundamental concept that has transformed the way we use and access computing resources. So, what exactly is cloud computing? Cloud computing refers to the delivery of computing services over the internet. It allows users to access and utilize a wide range of resources and applications without needing to have them physically installed or stored on their local devices. In simpler terms, the cloud acts as a virtual space where users can store data, run applications, and perform various tasks. In this video, we are going to discuss cloud computing vs distributed computing, the advantages and disadvantages of cloud computing, types of cloud services, practical examples of how cloud computing is used, and some best-rated cloud computing services to use. Cloud computing vs distributed computing. 1. Definition and architecture. Cloud computing refers to the delivery of computing services over the internet, utilizing remote servers hosted by a cloud service provider. Users access these services through a network connection, enabling on-demand resource allocation and scalability. In contrast, distributed computing involves the coordination and sharing of tasks across a network of interconnected computers, often referred to as a cluster or a grid. 2. Resource ownership and management. In cloud computing, the infrastructure, including servers, storage, and networking equipment, is owned and managed by the cloud service provider. Users lease these resources and are responsible for deploying and managing their applications and data within the cloud environment. On the other hand, in distributed computing, the resources are typically owned and managed by the organization or individual utilizing the distributed computing infrastructure. Users have more control over the configuration and management of the resources. 3. Scalability and elasticity. Scalability is a shared characteristic of both cloud computing and distributed computing. However, they differ in terms of scalability models. Cloud computing offers elastic scalability, allowing users to quickly and easily scale up or down their resource usage based on demand. This is achieved by leveraging the provider's infrastructure and capabilities. In distributed computing, scalability often requires more manual configuration and coordination among the distributed nodes. 4. Application focus. Cloud computing is primarily focused on delivering services and applications to end users over the internet. It emphasizes ease of access, flexibility, and cost efficiency. On the other hand, distributed computing often targets specific applications that require high computational power or involve parallel processing. Distributed computing is commonly employed in scientific research, big data processing, and complex simulations. 5. Fault tolerance and reliability. Cloud computing platforms typically provide built-in redundancy and fault tolerance mechanisms across their multiple data centers. This ensures high availability and reliability for users. In distributed computing, fault tolerance and reliability are achieved through redundancy and error handling mechanisms implemented within the distributed system itself. Nodes within the system may collaborate to handle failures and maintain system integrity. 6. Data and task distribution. In cloud computing, the distribution of data and tasks is managed transparently by the cloud provider. Users interact with abstracted resources and do not need to be concerned with the underlying distribution mechanisms. In distributed computing, users have more control over the distribution of data and tasks. They explicitly define how data is partitioned and spread across the nodes. Advantages and disadvantages of cloud computing. Advantages. 1. Scalability. Cloud services can be easily scaled up or down to meet changing needs. Users can access additional resources or reduce their usage based on demand, allowing for flexibility and cost efficiency. 2. Accessibility. Cloud services can be accessed from anywhere with an internet connection. This accessibility promotes mobility and allows users to work and collaborate remotely. Whether you're at home, in the office, or on the go, you can easily access your data and applications. 3. Cost savings. Cloud computing eliminates the need for upfront investments in hardware and infrastructure. Users can pay for resources on a pay-as-you-go basis, reducing capital expenses and allowing for better budget management. This cost-saving aspect has made cloud computing particularly attractive for startups and small businesses. 4. Reliability and redundancy. Cloud service providers typically have multiple data centers spread across different locations. This redundancy ensures high availability and reliability, with built-in backup and disaster recovery mechanisms. Even if one server or data center experiences an issue, your data and applications can still be accessed without disruption. 5. Security. Security is a top concern for many when it comes to the cloud. Cloud providers implement robust security measures to protect user data. They often employ encryption, access controls, and regular security updates. In many cases, cloud services offer better security than what an individual or organization could achieve on their own. Disadvantages. 1. Dependency on internet connectivity. Cloud computing relies heavily on internet connectivity. Without a stable and reliable internet connection, users may experience difficulties accessing their data or applications. This dependency on connectivity can pose challenges, especially in areas with limited or unreliable internet access. 2. Data security and privacy concerns. While cloud providers implement robust security measures, some organizations and individuals may have concerns about data security and privacy. Storing data on remote servers raises questions about who has access to the data and how it is protected. Compliance with data protection regulations and ensuring appropriate access controls are crucial factors. 3. Potential service disruptions. Despite the redundancy measures in place, cloud services can still experience outages or service disruptions. These disruptions can impact user access and productivity, especially if they occur during critical times. It's essential for businesses to have contingency plans and backup strategies to mitigate the impact of such disruptions. 4. Limited control and customization. Cloud computing entails relying on the infrastructure and services provided by cloud providers. This reliance limits the level of control and customization that users have over their environment. Users may face restrictions in terms of software versions, hardware configurations, or specialized applications that may not be supported by the cloud service provider. 5. Data transfer and vendor lock-in. Moving data to and from the cloud can be time-consuming, especially when dealing with large volumes of data. Additionally, once a user adopts a specific cloud provider and architecture, transitioning to a different provider or migrating data can be challenging. This potential vendor lock-in should be considered when evaluating cloud computing options. Types of cloud services. 1. Infrastructure as a service. Infrastructure as a service, or IaaS, provides users with virtualized computing resources over the Internet. With IaaS, users have access to virtual machines, storage, networks, and other infrastructure components. They can build and manage their own IT infrastructure within the cloud environment. Users have more control and flexibility to configure and customize their virtual infrastructure, including operating systems, applications, and security settings. 2. Platform as a service. Platform as a service, or PaaS, provides a platform and environment for developers to build, deploy, and manage applications without the complexity of underlying infrastructure management. PaaS offerings typically include tools, frameworks, development environments, and runtime environments. Developers can focus on writing code and creating applications without the need to worry about the underlying infrastructure. PaaS providers handle the infrastructure, scaling, and maintenance aspects. 3. Software as a service. Software as a service, or SaaS, delivers software applications over the Internet on a subscription basis. With SaaS, users can access and use software applications directly through web browsers without needing to install or maintain the applications locally. The software is hosted and managed by the SaaS provider, who handles maintenance, updates, and security. SaaS applications span various domains, including email services, customer relationship management systems, collaboration tools, project management software, and more. Here are some practical examples of how cloud computing is used in various domains. 1. Storage and data backup. Cloud storage services, such as Dropbox, Google Drive, and Microsoft OneDrive, allow users to store their files and data securely in the cloud. These services provide easy accessibility, synchronization across devices, and automatic backups, ensuring that data is protected and accessible from anywhere. 2. Software development and testing. Cloud-based development platforms, like GitHub and GitLab, provide collaborative environments for developers to collaborate, version control their code, and manage software projects. Additionally, cloud-based testing platforms, such as Source Labs and BrowserStack, allow developers to perform cross-browser and cross-platform testing on virtualized environments. 3. Web and mobile applications. Cloud computing enables the hosting and scaling of web and mobile applications. Platforms like Amazon Web Services, Microsoft Azure, and Google Cloud Platform offer infrastructure services, such as virtual machines, containers, and serverless computing, allowing developers to deploy and scale their applications on demand. 4. Big data processing and analytics. Cloud platforms provide powerful tools for processing and analyzing large volumes of data. Services like Amazon S3, Google BigQuery, and Azure Data Lake allow businesses to store, process, and analyze vast amounts of data using distributed computing and parallel processing techniques. Cloud-based analytics platforms, such as Google Analytics and AWS QuickSight, offer insights and visualization capabilities. By the way, what is big data? Let me know in the comment section. 5. Artificial intelligence and machine learning. Cloud platforms offer pre-trained models and scalable AI and machine learning applications infrastructure. Services like AWS SageMaker, Google Cloud AI Platform, and Azure Machine Learning provide the tools and resources to develop, train, and deploy machine learning models at scale. These platforms also offer APIs for image recognition, natural language processing, and sentiment analysis. 6. Video and media streaming. Cloud-based video and media streaming services, such as Netflix and YouTube, leverage cloud infrastructure to deliver high-quality video content to a large number of users simultaneously. Cloud-based content delivery networks ensure fast and reliable content delivery by caching content in geographically distributed data centers. 7. Collaboration and communication. Cloud-based collaboration tools, such as Google Workspace and Microsoft Office 365, enable real-time collaboration, document sharing, and communication across teams. These platforms provide cloud storage, email, document editing, video conferencing, and other productivity features. These examples illustrate the diverse applications of cloud computing across different industries and use cases. Cloud computing's scalability, accessibility, cost efficiency, and ease of use have made it a vital technology for organizations of all sizes, from startups to large enterprises. These examples illustrate the diverse applications of cloud computing across different industries and use cases. Cloud computing's scalability, accessibility, cost efficiency, and ease of use have made it a vital technology for organizations of all sizes, from startups to large enterprises. Finally, here is information about some of the most popular and highly regarded cloud computing service providers based on historical data and industry reputation. It's important to note that the best cloud computing service for you will depend on your specific requirements and priorities. Here are a few well-regarded cloud service providers. All the links are in the description. 1. Amazon Web Services. AWS is a market leader in cloud computing, offering a wide range of services across all three cloud models. It provides a comprehensive suite of services, including computing power, storage, databases, machine learning, analytics, and more. AWS has a vast ecosystem, global infrastructure, and extensive documentation and support resources. It is known for its scalability, reliability, and flexibility, making it a popular choice for businesses of all sizes. 2. Microsoft Azure. Azure is another major player in the cloud computing market, offering a broad range of services and solutions. It provides a comprehensive suite of cloud services, including computing, storage, networking, databases, AI, and IoT. Azure integrates well with Microsoft's existing software and development tools, making it attractive for organizations using Microsoft technologies. It offers hybrid cloud capabilities, enabling seamless integration between on-premises infrastructure and the cloud. 3. Google Cloud Platform. GCP is Google's cloud computing platform, offering a wide array of services for computing, storage, networking, machine learning, and more. GCP is known for its scalability, reliability, and advanced analytics capabilities. It provides tight integration with other Google services and tools, such as BigQuery, TensorFlow, and Google Workspace. GCP offers innovative solutions in areas like AI, machine learning, and data analytics. 4. IBM Cloud. IBM Cloud offers a range of cloud services, including IaaS, PaaS, and SaaS, designed for enterprise-level workloads. It provides a suite of services for computing, storage, networking, AI, and blockchain. IBM Cloud is known for its focus on enterprise needs, security, and compliance. It offers a hybrid cloud approach, allowing integration with on-premises infrastructure. It's essential to conduct thorough research and evaluate these providers based on your specific requirements, such as pricing, scalability, performance, support, and integration capabilities. Additionally, consider reading user reviews, consulting with industry experts, and conducting trials or proofs of concept to assess the suitability of a cloud provider for your unique needs. If you know any other cloud service providers, make sure to comment below. Conclusion. Cloud computing has revolutionized the way individuals and businesses manage their IT needs. It offers scalability, accessibility, cost savings, reliability, and enhanced security. Whether you're a small business owner, a developer, or an individual user, leveraging cloud computing can provide you with the computing power and resources you need, when you need them. Cloud computing offers undeniable advantages such as scalability, cost savings, accessibility, reliability, and security. However, it's important to be aware of the challenges, including internet dependency, data security concerns, potential disruptions, limited control, and potential vendor lock-in. By carefully considering these pros and cons, individuals and businesses can make informed decisions when adopting cloud computing solutions. Cloud computing and distributed computing offer distinct approaches to harnessing computational resources. Cloud computing focuses on delivering services over the internet, emphasizing scalability, ease of use, and cost efficiency. Distributed computing, on the other hand, leverages interconnected resources owned by the user or organization to handle specific applications with high computational demands. Understanding the differences between these paradigms is crucial in selecting the most suitable approach for specific use cases. That's it for today's episode on cloud computing. We hope you found this overview informative and gained a better understanding of this transformative technology. Be sure to join us next time as we delve into more exciting tech topics. Until then, stay curious and keep exploring the possibilities of technology.